Hello, boys. Good morning. Uh, how is going on? Everything. Hope all of you are safe and your family members are also safe and healthy. And we are just in our review session, review classes, and in after finishing our review classes, I hope. We hope that you will have a very good preparation for your test exam, and you will also can get very good marks on your board exam also. Boys, in my last class I just tried to discuss about chapter 2 creative type question, because we have finished the theory based discussion on regular classes, and so there is no need to or urgency to discuss the theory type questions, or discuss the theory based topic. In this chapter you have got the idea about force and kind of force. You have known about Newton's laws of motion, three laws there, about motion, about force, about momentum. You have known about momentum, conservation of energy. Lots of things are there in this chapter, and this is an important chapter also for board question, because no one can predict which chapter is will be chosen for board exam, because only the question maker can say this, from which chapter the question will come. So we have to make a very good preparation on all chapters, because our target is to get a good marks. So um, now let's start our class with a new creative question from chapter 4, that means chapter 3, that means force. Here is a stain, that is a diagram based stain. In the diagram there are two objects of two different masses. First one is of spherical shape and its mass is 10 gram, and second one is of a rectangular shape whose mass is 20 gram. They are just released from a same height of 50 meter, and these are the information from our diagram. And in the stain, some points are also added here, that effective force of F1 of M1, that means effective force on first mass M1 is 0.078 Newton, and effective force of M2 is 0.039 Newton. These two objects are released at the same time, and from the diagram we just can see this, the objects are released from same height also. They are released at same time from same height. So what are the questions according to this thing? First one is, what is balanced force? Second one is, mass of object is constant but weight is not constant. Mass is constant but weight is not constant. You are familiar this term. Question number C, find out the frictional force of air on the object M1. That means we have to find the frictional force on first mass M1. And finally question number D, which object will reach the ground earlier? So first of all, our first question is, what is balanced force? You have learned about balanced force when two or more forces are applied on an object at a time. That means parallelly two or more forces are applied on an object, and if the combined resultant force of all acting forces becomes zero, that means the net or resultant force is zero, then the body remains stationary, though we are applying forces, several kinds of forces on that object, but the body remains stationary, and the forces are called balanced force. So what is balanced force? The resultant force remains stationary as the after effect of all applied force, the resultant force is zero. That's why the body remains stationary, and the forces are all of applied forces are called balanced force. Our question number B is mass is the weight changes but mass is constant. What is the reason, or what is the logic behind it? As we know that mass is the total amount of substance or total amount of element in an object, and that doesn't change with the change of place, with the change of situation. Total amount of element of an object doesn't change, but in terms of the weight is the product of mass and gravitational acceleration or acceleration due to gravity, that means small g. Mass weight is the product of m and g. So m is a constant value, but g is related with the radius of the earth, and the radius earth is not a perfect sphere, so the radius is not same at all end of the earth. So due to change in radius, the value of gravitational acceleration changes, and due to this change the weight on of an object also changes. But in terms of mass, there is no possibility of changing the mass. That's why the mass is constant, but the weight is a value that can be changed. Our question number C is what is the frictional force on object m1 or on object of mass m1. Listen here, just if you observe the question, if you follow the question, in question the forces are given as effective force, not as applied force. Whenever there is frictional force, and then the applied force is the sum up of frictional force and effective force, because the frictional force, some applied forces are just lost, or some applied forces can't work totally, so there is some loss also. So total applied force is will be effective force plus frictional force. As in the stem, the frictional force is active here. The objects are just falling from a definite height, and due to the air, the object will have the object will feel a resistance in falling. So due to that, the total effective force will be the applied force minus frictional force. If we just see the simple diagram here, the weight of the object is acting in the base, and the applied force is also acting on the base, because the acceleration, due to the acceleration of gravitational acceleration, the object will fall towards the base, but the frictional force will act in opposite of the applied force. So here we can write the effective force F1 plus frictional force small f1 is equals W or mg. We can write it here because the total force is the sum up of effective force and frictional force. Here effective force is F1 and frictional force is small f1, and from this relation we can just determine the frictional force small f1, and we have to convert the given mass into SI unit, that means in kg. 10 gram is equal 0.01 kg, and effective force is given in SI unit, so we have no need to convert it or change it. Then we will finally get the frictional force F1 is equals W minus effective force capital F1, and after calculation we will get the frictional force will be 0.02 Newton. if the frictional or if in our question, instead of telling about effective force, if the applied force was given, we could write the equation as F minus Fk is equals W. This is whatever I'm trying to say to you, that if in question applied force is given, and then if there is a frictional force, then the active force will be for example F dash, then the total applied force is equal active force or effective force plus frictional force. In our present thing, or the in the math, the active force or effective force is given, so we have chosen the relation F prime plus F, that means effective force plus frictional force equals Ma or Mg. But if in question instead of applied effective force, if the applied force was given, then we could write it as F minus F equals Ma. That means applied force minus frictional force equals Ma or Mg. We will just write the equation according to our situation. Whatever is given on our stem, we will choose the equation according to that. Our question number D was which one or which object will fall to the ground first, or whether they will just as they are released at the same time, will they just fall at same time or not. This was our question number D. For determining it, we have to make a relation between the time t1 and t2, that means the time taken by object 1 and object 2. For determining that, we have to measure the acceleration here. The acceleration for first object, that means object of mass m1, will be a1 equals f1 divided by m1, and f1 is given in our question, m1 is also given, so we can just determine the acceleration a1, that will be 7.8 meter per second square. At the same as as the same way, we can determine the acceleration for the object 2, that will be a2, and this will be just 1.95 by applying the values on the equation f2 by m2, and finally the acceleration for second object will be 1.95 meter per second square. But our motive is to calculate the time here, so we will just follow the Newton's laws of motion, the equation of motion. We will just use the equation of motion here, and for if the height is involved here, for measuring the height, the equation of motion is h is equals ut or v naught t plus half at square or half gt square. As the objects are released from a specific height and they are just approaching to the ground, they will have acceleration, and the acceleration will be different for different objects as the masses are not same here. So for first object, if the height is h2, then the h2 equals v naught t2 v02 t2 plus half a2 t2 square, where v02 is the initial velocity, t2 is the time taken by the second object for falling to the ground, a2 is the acceleration, and if we write the term h1 is equals v01 t1 plus half a1 t1 square, and v01 is the initial velocity of the first object. As the object is released from a rest position, so their initial velocity will be 0 for both. That means v01 and v02 will be 0 here, and just applying these value over in this equation, we will get h2 by h1 is equals half a2 t2 square divided by half a1 t1 square. But in our question, the height is same for both objects. That means they are released from same height of 50 meter. That's why h1 is equals h2, and so the left side will be 1 here, And if we just make a ratio of t2 by t1, t2 by t1 is equals root over a1 by a2. And we have calculated the values of a1 and a2 earlier in this question. So after putting the values here, we will get that t2 by t1 is equals to, that means t2 equals 2t1. And these just by following this equation, we can make a declaration that the time for the object t2 will be greater than the time for object t1. That means t1 will just reach to the base first and then t2. So this is related to the force. This question is related to frictional force, related to height, and equation of motion for freely falling bodies. Some different kinds of topics are just combined here in this question. And I think you will follow some other questions of different topic from this chapter and all the chapters in your book. First of all, you just make a thorough reading, make a thorough revision on your textbook, then just try to solve some MCQ type questions, some creative type question, and then we will you will be able to make a proper preparation. So while today's class is just today's class is over here, and in our next class we will discuss some other topic. Stay safe. Goodbye.